your name in the chat though, so when I take attendance, I make sure that I got you. Okay. I don't know what to do. I'm just gonna leave you right there for a second. Awesome. Thank you. Who we got? Let's see. Here. I'll stay with the screen over here. So
Is Core A like really behind now?
they're not, because they're either logging in live right now or they're going to watch the video before tomorrow.
Okay.
Now, I don't know exactly what I want tomorrow to look like yet, but I will let you guys know tonight whether or not you need to log in live or not. I haven't decided. I guess we'll kind of see how far we get. And I might just give you practice with that, and then we can just kind of pick stuff up from there.
Rosie,
what's up?
Work.
Huh?
I said, can we not log into a Zoom call? I have to go to work.
I'm leaning that direction anyway.
Yay! Okay, cool.
I'm leaning that way. Mostly because I'm mad at us. So not necessarily you particularly, but just us in general. Is this everybody? I feel like we're. Let's see. Let's check some attendance, and then I'll give you the lowdown on where I'm at. All right, period 7. Colton, Bree, Abby, Colton, Peyton, Griffin, Jared, Tate, Caitlin, Sam. Let's see. Where are these people? Now there's no bells, so that makes it a little bit trickier. So I'm going to wait just 1 minute to see if we get any stragglers to come in. That'll give me a chance to actually upload something on Canvas for pre-calc that I did not get a chance to do yet. All right, you're going down there. Copy. Reload. Edit. Yay, there's Griff. What's up, buddy? September 24th, 2020. That was period 4. All right, cool. Griff is here, sweet. Have we seen Jared or Sam Medina today? No. Okay. All right. This way you can see me while I talk. Sort of. Quality should be much better though, which is awesome. All right. All right. So here's what's happening. I gave everybody the opportunity that needed to come forward about dishonestly taking that quiz number 0, and not everybody did. Some people did, and I applaud those that were willing to say, you know what, Rosie, I messed up. But through that experience, hi, Miss Lopez, what's up? Huh?
How are you?
I'm wonderful.
How about Sanford?
Yes, you may.
I'm supposed to come Tuesday for that one. My calendar called me.
It's all good. Through some of those conversations with the people that were honest with me about their dishonesty, I found out that it really wasn't just one question that I should be worried about, but that the entire quiz ended up on Snapchat. And so now, next week, Monday for cohort A, Tuesday for cohort B, we're taking it again, which sucks for the people that didn't cheat. But don't blame me. Blame the handful of people that decided that their notes and their help from the teacher was not enough to do well on a quiz that we have been practicing for weeks. So here's what you're going to do. You guys in front of me are going to show up on Tuesday, and you're going to bring your quiz with you. Bring that old quiz with you. Okay? And I'm going to have a new one made up. Similar questions, but just different numbers. Okay? Probably have to be a little bit shorter because we only have 50 minutes to do it in. Now, if you have accommodations that allow you like time and a half or double time or anything extra, of course, I will accommodate that. But the problem is that I can't stick around after this class to do it for very long. If you get time and a half, I can probably manage that extra 25 minutes because we're done around 2. I have to leave by like 2:30, 2:45 that day. I have to get my kids early from daycare. My daycare lady has a doctor's appointment for her son. So I have to leave school before school is out that day. So if you get time and a half, you can just stay through. If you get double time, it might be cutting it a little close, but we can make it work. But I'm not mad, I guess. I'm just like disappointed because what else did I need to do to show you that I'm willing to help you get the best grade possible, then give you a chance to use your notes, do a ton of practice in class. And now I can't send you home with anything we do for correctness until we somehow mend the trust that is now broken. And it is a vast minority that broke that trust. And now everybody has to pay those consequences, which sucks. It just sucks. And so I guess I'm not mad. I'm just disappointed that we got to this point after what I felt like I did the best that I could to show you how helpful I am, how much I want you to do well. And I don't know who it was that put it on Snapchat. And if they want to speak up, great. If they don't, that's fine. But I know it's true. And that just bugs the hell out of me. And I keep hearing from some people like, Rosie, I didn't do my homework because I didn't want to cheat and I want to ask you for help and I just want to learn. I feel like you're one of the only teachers that actually like has my best interest at heart. And I thought that was true. But then other things happen. So this just sucks. But I want to put this behind us. I want to literally turn the page and do something different today. We're going to have to come back, you guys on Tuesday, you guys on Monday, and we're going to do it again. With notes, for sure. But we only have 50 minutes to do it. And so we're going to get into class. We're going to be just like this. The quiz will be waiting for you. As soon as you get here, you can start. Okay? So expect that. Which means I'm not going to have other things for you to do in preparation for Monday or Tuesday. Okay? The new stuff that we do today, I'm not going to have you have something due Sunday night or Monday night with this stuff. We'll just have to kind of pick it up on Wednesday and Thursday next week. Okay? So to the vast majority of the people in this room, and maybe literally everybody in this room sitting here right now, thank you for doing the right thing. And find the people that didn't do the right thing and set them straight. Like they are ruining your chance to do well. Because now we've done two different things and now you have to go back. So let's not do this again, okay? Let's not do this again. Good? Thank you. All right. All right, let's switch gears. Let's do some new stuff, okay? Take us something to write with, something to write on. Let's start section 1.2 today. Now, I'm going to be bouncing around a little bit from one board to the next. So for this recording, I'm going to try to take you guys with me as much as I can. And you can always go back and rewatch and pause stuff. And I know that there's some glare, so I'm going to try to talk through this as much as I can too. But you are going to want to have a graphing calculator out or your phone and either opening a graphing calculator app if you've got one, like Desmos, or just going to desmos.com. I don't care if it's on a laptop or on your phone. But what I want to look at now, I still want to stick on the visual side of things, but I want to talk about how I can look at an equation for a graph, but not actually look at the graph and know what it's going to look like. I want to know the changes that maybe have happened. So this is section 1.2. So And so that says 1.2 right there. And I want to talk about, let's pick some good colors so stuff stands out, hopefully. If you ever want to buy me something, Expo markers. Oh, and like mocha coffees, or really anything with chocolate, that's good. But Expo markers, always fun. Let's talk about transformations. Changes. Just things that are changing of functions. Okay, so over the top there, that just says 1.2 transformations of functions. Okay, and so what I'm going to do over here on this board is I'm going to go write down some examples and some ideas that we come up with. But over here on that board is where I'm going to put a big flow chart. I'm going to fill up this whole board that's going to take you about half a page. So you want to be on a page where you can write like top half of stuff up here, but make sure you save the bottom half of this page for whatever I write over here, which is going to be what I'm going to call a transformations flow chart. To make it really easy to look at an equation and describe the things that are different. Okay, and when I go over there, I'm gonna bring you guys with me a little further, but I'm gonna be over here for right now. The other thing that I'm gonna do is I'm gonna be in my graphing calculator because I'm just gonna look at it. I want you guys to come up with some good names for the changes that are happening. So open up your graphing calculator or go to Desmos.com or open up an app on there. I'm gonna do the same thing here. So I'm going to start presenting from here so you guys can see. And if you're at home, you should be able to see both, me presenting my screen and physically me right here. So you can pin whatever you want. The recording is going to focus mostly on what I'm presenting. So I'm going to kind of go back and forth a little bit.
So do we have to go to the app?
Say that again.
Are we going to the Desmos like website or app?
Yes, that'd be perfect. This way you can see it. But honestly, you're seeing my screen, so you can just kind of watch too. That's cool.
Oh, thank you.
So you don't have to, but you guys can see a little better at home. And all of these work no matter what the function is, no matter what it looks like. Line, circles, square, whatever kind of graph I'm looking at. So I'm going to pick one function and just run with it the whole way, but it works no matter what kind of function we're looking at. I'm going to talk about whether I call it y or f of x doesn't matter. So I'm going to talk about just plain old x squared. And so if you've got your calculator or your phone in front of you on the Desmos app, graph that. Look at it. And as we go through, I really want to try to get to a point where you're comfortable in the graphing calculator. The more stuff you know how to use in there, the better you can do on things like tests or high-stakes stuff like the SAT that the seniors took yesterday. And there's definitely some Algebra II level stuff on that SAT. I got a chance to look a little bit, not much, at it. And there's some statistics stuff. There's some Algebra II stuff. So do you know what kind of function that is? If the biggest power, in this case, the only power is a 2, you know what type of function that is? Like the name of that function? Starts with a Q. Nice, good, quadratic. And honestly, any function whose biggest exponent is a 2, they're all going to be quadratic. You know what that shape looks like? Like if you actually graph it, you might have it in front of you. I love that. I know, I always ask, and people like that, right? It's like that nice little U shaped. Do you know what that's called? Nice. Spell it right. P-A-R-A-B-O-L-A. Parabola. Cool. And so when we start messing with this shape, because that's all transformation is, I'm just going to mess with the shape. It's always going to look something like this. We're just going to move it left, right, up, down, make it skinnier, make it wider, flip it upside down, whatever we can do to change the way this graph looks. But I want to know what those changes are without having to look at it. But to come up with these rules, we're going to look at it. Okay, and then we'll practice what it looks like without. So what I want you to do, if you haven't done it yet, go to y equals in your calculator, and in the first spot, so I call it y1, put x squared. So we always have the original to go back and look at. Let me just make sure that everything at home is happening the way I want it to. Okay, presenting and recording. I know that it might be a little tough to see at spots, so just let me know at home if you need anything. All right, back to it. All right, and what I want to do is I just want to compare that. Okay, so in y2, so leave y1 there, but go to y2 and do like x squared plus 3. I don't know, let's just add something to it at the end. So go to y equals, leave y1, x, can I do that? You guys still see? X squared, and then at the end, throw a little plus 3 on the end. And then graph it. Okay, and what I want you to decide, you guys sitting in front of me right now, if you don't have it up, here it is. What's different? Transformations, what's changed from the blue original graph to the new red one? Well, how would you describe what's different?
Shifted 3 units up.
Perfect, up 3, and in my ear, I just heard shifted 3 units up. It just moved up 3 spots, and I think that's a great way to describe it, okay? So I like that idea of saying shift. I think that that's a great word to use when we talk about the types of transformations that we're going to be dealing with. And plus 3, it moved up 3, and that kind of makes sense, right? Plus 3 to me sounds like up, right? Plus goes up, minus goes down. I get that. That's cool. And so if we tried a different one, and let's drop it into like y3, like x squared minus 4. So I'm going back into y equals x squared minus 4. What's different? What happened? How would you describe what happened from the original blue graph to the new black one? Okay. Shifted down 4. Perfect. Now, when we talk about up and down, because one went up, one went down, what's a word that kind of encompasses both of those? When we talk about changes in this direction, what's a good word that means both up and down, or up or down?
Shifted.
But I like just the up and down part, not the way it moved up or down, but just when I say up or down, what's one word that encompasses both of those directions? That's a weird way to ask the question, but if I draw a line that goes up and down, how would you describe that line? Straight for sure, but because it's up and down, like that's a straight line too, right?
Perpendicular? Is that what you're trying to do?
No, not perpendicular.
Oh.
Just up and down. That line right there. That is it's only one line that goes up and down only. No angle to it. Doesn't go left to right. Ooh, there it was. Vertical.
Vertical.
Vertical. These type of changes are just vertical changes. And honestly, when we start describing these transformations, you're coming with me. Here's the key part. So now you're at like the bottom half of your graph. I wish I could disconnect the camera from my laptop, but that doesn't make any sense. When we talk about these type of transformations, there's going to be 1, 2, 3, 4 things we have to say. And the first choice that we're going to make is whether or not that transformation is vertical. And so in green, that I just dropped, are the words you're actually going to say. That could be one of the words you describe. And the way that we're going to tell how to do it, so I'm going to, where is the change happening? Is it a vertical change? That's one of these options. right? And so vertical shift up 3, vertical shift down 4. Or it could be something else. And so let's take a look at a different option. So the change could happen up and down. Another option for this change, let's switch colors so it stands out. Let's leave Y1 as Y1. But let's clear out everything else if you have that other stuff in there. I'm going back, I'm getting rid of this, I'm getting rid of this. What if we had Y2 not as x squared plus 3 with the plus 3 kind of at the end? And by the way, what's 2 plus 3? Easy question. 5. What's 3 plus 2? Does the order matter with addition? So if I put it at the front or I put it at the end, doesn't matter. I'm always going to put it at the end, though, when we're talking about adding and subtracting. But what if I put that plus 3 somewhere else? What if I instead put x plus 3 on the inside of some parentheses and then put the square on the outside? Is this equation in green, the x squared plus 3, and this equation, x plus 3 squared, are those the same? They don't look the same, so the results are probably going to be different. Let's take a look at what happens and see if you can describe. So if you've got your calculator, drop it into Y2. That's what I'm doing. So I've got Y2 in there. And I want to look at the change and see if we can describe what happens. So I'm just going to graph. Did this move in a vertical up and down kind of direction? Did your original blue graph and now your new red one, did it move up 3? No, which way did it go? The blue is the original, the red is the new one. Which way did it go? It went left. Now, the weird part about this to me is that the change happened left and right. And when it was just plus 3, okay, I went up 3. That's the direction that makes sense, right? And down 4 for minus 4. Now, to me, when I'm moving left and right, which direction is the positive direction? This way, right? This is where positive numbers go. But which way did we move in this graph? The other way. Okay? What should we call left and right changes if we said vertical for up and down? What's this direction? Not vertical, but horizontal. Good. And the changes that we might be dealing with when we've got addition or subtraction, so it's still a shift, right? We're still just moving, but it might be happening in the left and right direction instead. And what I want us to kind of get a feel for with this, all right, so it just says vertical or horizontal for option number 1. We're going to say one of those two words. It can't be both. We can't do both at the same time. We'd have to use different transformations to do it, and we're just going to name one at a time. If I want to describe whether or not my transformation happens up and down, whether it happens left and right, like let's take a look at this difference. Like, okay, y cubed, or y sub 3, x minus 4 squared. All right, let's look at that one. X minus 4 squared. Let me go back to, okay, I'm still presenting to you. And I'm gonna get rid of the red one just for a quick sec here when I graph. So from the blue one to the black one, which direction did it go? And how far do you think it went? X minus 4 squared. How many places did we move it? Probably 4, right? Absolutely. The number tells you how far you're going to go. But when we talk about left and right, which way feels like minus on the number line? Which way do the negatives go? This way, right? But which way did the graph go? Okay. Horizontal transformations are backwards than you expect. And that can be kind of frustrating to deal with. But like vertical shift, up 3. Vertical shift, down 4. Horizontal shift, well, to me, plus feels like right. So which way did we go? Left. X minus 4 squared. Which way does minus feel like to me? It feels like I should be going this way. So which way are we going? That way. We're going right. Okay? Horizontal transformations are backwards than the way we would expect. Okay? And so let's start to fill this flow chart out, and then we can get a good sense for what we're doing. Okay? So the first word that we're going to say, the first thing out of our mouth, is whether or not this thing is vertical or whether it's horizontal. And what I want us to try to figure out is how can we tell whether it's one or the other? How can you look at those equations and decide, is the change happening this way or is it happening this way? Take a look at what's in green versus what's not. Look at your vertical changes versus the horizontal. What's the difference? It's still +3 and -4. Where is that change happening? If it's horizontal, look at the ones on the right. The +3 with the purple, the -4 with the red. Inside the parentheses. What's inside with the +3 and with the -4? Look at those equations. What else is in there? Just x. Which axis runs left and right? The x-axis. If I want to change things in the horizontal direction, I better be changing x, not anything else. Okay? Horizontal changes. So the words we're going to say are in green. The way we're going to figure out how to pick can be in the different color. Okay? If I want a horizontal change, it better be inside something. I better be changing x. Okay, what's on this board right here has to be in your notes if you're going to make sense of this, because this is going to take us 2 classes to even just fill this thing out. But the more you have up here, the easier this gets. Okay, the words that we're going to say are in green. How we're going to figure it out is in this magenta. Okay, horizontal changes happen inside. It's got to be changing x to do it. Okay. Now, look at the ones that gave us those vertical changes. The ones in green from the beginning. X squared +3, x squared -4. Were those +3s and -4s, were those inside any parentheses? Do you even see any parentheses in those green equations? No. Vertical changes happen on the outside. Outside the parentheses. So it could be like right out front or at the end. I don't care. Doesn't matter. I'm not inside changing anything if I'm making a vertical change, if it's going up or down. And once I make the choice, vertical versus horizontal, step 1 done. Okay? The next thing that we have to decide is the type. What type of transformation is it? And so far, the only one that we've got is a shift. And so the word, and there's going to be 3. 1, 2, 3. So there's 2 options for this. It could be vertical or horizontal for where the change is happening. It's happening in a vertical direction or it's happening a horizontal one. But the type of transformation that it is, that's what it says up there, what type of transformation. The first option is a shift. And I am going to very often enunciate the F in the word shift when I talk about this. You get what I'm saying? So there was one time I was teaching a lesson in math. It was like my second year, like maybe it was my first year. This is my 10th year teaching. And I was teaching a lesson about like greatest common factor. And I was like, hey, I've got 2 x's over here and 1 x over here. How many can I take from both without taking too many? Like, can I take 2 from both hands? No, because this one doesn't have 1. So how many can I take without taking too many from both? I can only take 1. And so this is, I'm like 25, right? And I go like this. I can take 1, and I drop down 1 finger here, and I turn this hand around, and which finger do you think I put down? And so a bunch of 9th graders, I just go whoosh, and I flip them. So bad. And they all just looked at me like, you know, when teacher like says a bad word in class, but I'm just like, how many are left? This many. I was like, oh God, it's freaked me out. Okay, so shift with an F. Now, how can we tell if it's a shift? It's all about how the number's connected. Plus 3 minus 4. Plus 3 minus 4. It has to be connected by addition or subtraction of some number. So addition or subtraction of a number. Now, remember, this is a flow chart, okay? And so there's a flow that's going to happen here, all right? First word you're going to say is vertical, horizontal. It's going to be one of those two. The next word you say is going to be one of these three. And right now, the only one that we've got is shift. And so it could be a vertical shift or horizontal shift. So I'm not going to draw any arrows here. But the moment you say shift, it kind of limits your next set of options. Okay? When we give you this one, I'm going to go to here. When I give you this one, we're actually going to stop and be done. Okay? So if you got a vertical shift, the next thing I want to talk about is what direction it went. Vertical shift, up 3. Vertical shift, down 4. Horizontal shift, left 3. Horizontal shift, right 4. The only options we have, so in green, because these are the words we could say, could be left, or it could be right, it could be up, or it could be down. Okay, and realistically, the or, left or right, up or down. I'm not going to say or, I'm going to pick one of those. Vertical shift, up 3. Could it be a vertical shift, left 3? A vertical shift, left? No, I can't mix those two up, right? And so once I make a choice, vertical, horizontal, I can't say a horizontal shift down 7. Horizontal shift down doesn't make any sense. So really, when we say left or right, that's got to be a horizontal change. I had to have said horizontal from the beginning. If it's going to be up or down, whichever one it is, that has to be a vertical change. It's got to be. Got it. But the vertical changes are the ones that are going to happen in the direction I would expect it to. Right? Plus felt like up and it went up. Minus felt like down and it went down. Your vertical changes are going to follow common sense. They're going to use your intuition. These changes are intuitive. Vertical changes follow common sense. Plus goes up, minus goes down. Okay, I'm calling that intuitive. Sorry, I spelled it wrong. That would help. Intuitive. Sorry. Intuitive. It follows your intuition. Intuition is what you expect to happen. My intuition tells me that when we show up on Tuesday to retake this quiz, there's going to be a lot less cheating than there was when I gave it to you at home. That's what I expect. That's my intuition. Horizontal changes are backwards. They're not going to follow your intuition. In fact, they're going to do the exact opposite. Okay? The opposite of intuitive. Use this in your next English essay. Counterintuitive. One word. Counterintuitive. The opposite of what you'd expect. Counterintuitive. A counterstrike. Right? Counterculture. The opposite. Horizontal transformations are backwards. If you think you should be going right, you're going left. If you think you should be going left, you're going right. And it's really just based on the sign. So really, when we get to this point with part 3, it's really now not like addition or subtraction. It's like addition versus subtraction. It matters which one we've got to tell us which direction we're going. Okay? Vertical shift, up 7. Vertical shift, down 3. Horizontal shift, right 5. Horizontal shift, left 6. Whatever it was. Right? The last thing we have to say is how far we went, whatever that number is. Okay? So, how far? So in magenta there is how far. That's what we want to decide. But really, I just have to name whatever that number is. Okay, and let's try. That's enough for now. That's enough of notes. I want to actually give this thing a shot. And you're going to see that there's not a lot of work that needs to be done. It's analysis. It's looking at an equation and deciding what's different. So let's try. Number 1. Okay, it's going to make it up. I don't know, f of x, right? It's a function, so there's that function notation. This means y, though. F of x equals, let's go, x squared plus 6. And I want you to write these down with me because you're going to see how simple this can be once you get the hang of it. It's a lot to process early on, which is why I'm stopping at shifts, and we're going to practice shifts first, nothing else. But there's 2 other ones. Okay? All right, so let's take a look. So I'm back over at the flowchart. I have 4 words to say. 1, 2, 3, 4. The first choice we make is vertical or horizontal. Look at the equation. It tells you everything you need to know. X squared plus 6. And remember that what's in magenta tells us how to figure it out. Is the change, that plus 6, because it's just x squared, right? Is the change happening inside parentheses or is it happening on the outside? Well, are there even parentheses to worry about? Well, so can it be happening inside parentheses if there aren't any from the beginning? Perfect. The first word, and the only word I need to write down first, is vertical. Step 1 done. That's it. Now I look at step 2. Now I just decide what type of transformation is it. And the way that I can tell is whether or not the number is connected by either addition or subtraction. Is it? So what kind of transformation is it? The words in green are all we have to say. Shift. Vertical, shift. Part 2 done. Step 3. Now I have to really dig down and get a sense for what direction things are happening. We said vertical. Could it be left or right? We said vertical. I'm limited now to just up and down. Okay. Is it up or is it down? Plus versus minus. Now it makes a difference. Vertical changes happen in the direction you would expect. So we've got plus. Do you think that's up or do you think that's down? Up. Vertical, shift, up. Option number 4, just a number. 6. And guess what? Done. That's all you need to do with that question. Describe the transformations that have happened to this function. There it is. Next one. Let's call it g of x. And I don't know, let's go like x squared minus 5. Where is the change happening? Is it happening inside parentheses or is it happening on the outside? Outside, because there aren't any in the first place. So is that vertical or is that horizontal? Vertical. I'm going to take you with me a little bit. Okay. What type of transformation is it if it's connected by addition or subtraction? Got to be a shift. It's the only one we know so far, so we're feeling pretty good about calling this thing a shift. So the next word that I write down is shift. Vertical shift. Okay, now we pick a direction. Up, down, left, right. It can only be up or down, right, because it's vertical. Happens in the direction we expect. That's intuition tells us that minus goes down. How far down did it go? 5. Done.
Rosie,
Yes, question.
why do we put like f, x, or gx at the beginning of the
So the question was, why do we put f of x or g of x at the beginning? Because if I put y equals for everything, we wouldn't be able to tell them apart without having to say the whole function. I'd have to say y equals x squared plus 6, or y equals x squared minus 5. Whereas now I could just say, hey, look at f of x, or look at g of x. It's that function notation, and the letter in front is just the name. The first one is function f. The next one is function g. And we'll play around with like what that notation allows us to do once we get a little further into, I think, chapter 1, maybe even chapter 2. So it's just a name. You're welcome. It's just the name of the function. Yeah. Okay. All right. Let's do 2 more. And then I'll add one little piece at the end. And then, again, we'll pick it up another time. Let's pick a new letter. How about T for Tavia? Now, when I write my T's, look how I write them. I put a little tail on the end, because if I wrote it like that, what does that kind of look like in math? And I don't want it to be a plus. I want it to be a T. So I write it like that. Okay, it's kind of like a script version. You could write it like that too, you know, cursive. But I like to do it like that. So T of x, parentheses, x minus 7 squared. Don't fall. Come on. Come on with me. Come on with it.
Would it?
Hey. Oh, God. Don't die. You died. What's up?
Do we tell you what we think it's gonna be, or are you just?
Sure, go ahead. I'm the only one that can hear you.
Horizontal shift to the left, 7.
All right, let's see. Let's see if
Is
you're
that
right.
right?
We'll find out. Where's the change happening? Inside or outside? Now look at it. Right? It's all about what it looks like there. Is the addition or subtraction happening on the inside of the parentheses? So if it's inside, horizontal, what kind of transformation is it? It's the only kind we know, right? If it's addition or subtraction, no matter what, I don't care if it's vertical or horizontal, if it's connected, what type of transformation is it, plus or minus? So I know I can come over here and definitely say horizontal shift. Horizontal shift. Okay. Now we have to make the choice. Left, right, up, or down. Could it be up or down? No, we said horizontal. So our only options are left or right. Now, to me, minus feels on the number line. What do you think? Does minus feel to you? Where do the negatives go? This way, right? So in my mind, negative feels like left. So which direction are we going? We're going right. And graph it, you'll see it. It will have moved to the right. Which is just like range was kind of weird because we went from bottom to top. That kind of felt backwards. Same thing here. Horizontal transformations are counterintuitive. They're going to go in the opposite direction you expect. How far to the right? Whatever the number is. So. All right, last one. You can see over here. Cool. I'll go over here.
Mr. Rosenberg,
yeah, question.
why would it be to the right?
Because horizontal, the question is why is it to the right? Because horizontal transformations are not the direction we would expect. And the reason, if you look at the graph, you'll see it's true. But the idea is that like we used to have a graph that looked like this, that went right through 0. And I'll ask this to everybody out there, what number would you have to put right here for x to make the whole thing 0?
7.
What number would you have to put right there for x? That 7 might, that this minus 7 would be 0.
7.
What number should go right here to make all of this 0?
7. Can he?
Yeah.
7.
I hear you at home. I haven't heard anything here. What number goes right there? That this minus 7 is 0. 7. I only have half a year, and it's not the good one. In high school, I don't know if I told you the story. In high school, after school one day, this girl jumped on my back. She had a stick in her hand. She was poking me with the stick. and there's like a little twig from a tree. So she's going like this. And where does it end up? Boom! Right in my ear. Punctures my eardrum. 3 weeks later, it's like healed itself and scabbed. I had to go to the ear doctor. This is so gross. You guys had lunch a little while ago. I had to peel the scab off of my eardrum. My hearing has never been the same. So this is the good ear. That's why they're in the good ear. So that's why this thing is actually shifted 1, 2, 3, 4, 5, 6, 7 over to the right, because we want to make 0. That's all. All right, let's do one more. And then I'll touch on one last little thing. How about a new one? Here's a letter I'm not going to use very much. What letter does that look like? What number does that look like? And that can be really hard to tell the difference if you're not careful. So I'm not going to use S. I know you probably just wrote it. Don't. I'm going to try to avoid S as much as I can. How about K for Colton back there? How about that?
Yeah.
All right. There you go. I'll get you girls next. All right. X plus, I don't know, how about 1? X plus 1 squared. You've got the flow chart. Let's just use it. Horizontal or vertical? It's inside. Horizontal. What kind of transformation is it? The only one we know so far. And I'm guaranteed, because it's just plus. Plus or minus is all I need. Horizontal, shift. Plus to me feels like this way. So what direction am I actually going?
Left.
The other way. The other way. Right? We're going left. And think about it. What number to put right here to make all of this 0? -1, right? And that's that way. All right, that's why we get 0. Left, how far? 1. Okay? And so if you've got addition or subtraction, follow that kind of top level of that flowchart. All right, I've got 5 minutes. I want to show you the second of 3 transformations, just so you kind of get a hang of it. This one's a little bit trickier to come up with a good name for, but we'll see how we do. I'm not going to present. You can hear me talk about it, but I'd rather you see me. Okay, cool. Let's compare. Let's pick a different color. All right, new setup, okay? Y1 still x squared. Let's make Y2 like 3. Oh, that's a weird looking 3. 3x squared. So if you're graphing these, if you've got your calculator out, delete everything except for y equals x squared. And let's type in 3x squared instead. I'll present for a quick sec so you can see it, and then I'll take you guys off. I know you're just staring at the board. Okay. I'm here, I promise. Okay, cool. Let's go with this. All right, so take a look. Blue graph to right graph. Now, with all of these shifts, the whole thing moved. Every single point went left, right, up, or down. Look at the vertex. Look at that turning point at the bottom. Between the red and the blue, did it move? So it can't be a shift if the points are still there. So we need a different way to describe that connection, right? I've got this red to blue looking thing. And so what I'm going to do is I'm going to try to mime this out for you in a way that you can maybe come up with the right way to talk about it. Okay, so here it is. My arms are the problem. Describe what I'm doing physically when I go from this x squared to 3x squared. Physically, not math. Physically, what are my arms doing from here to here? Going up, for sure. Absolutely. And every point's going up except for the middle. So I don't want to say, like, going up, because not everything is doing that. The arrows, like at the end, like my fingers, the arrows, they're definitely going up. But let's talk about, like, physically, me, my body. Like, if I was in, like, PE class, I'll make a face, maybe that'll help. Say it louder. I thought I heard whispers. That whoever's starting with this, I hear like there's a snake in here, huh? Stretching. That's what it's called. Like literally, that's the mathematical term for what happens. Nice. That took period 6 like 10 minutes. We came up with 100 great words to describe it, but stretch is perfect. Now, there's actually two options here. So I'm going to say stretch or, and this is not the next option. There's another one that we can talk about. But how is the 3 in that red, like the 3x squared, how is the 3 connected to x squared if I don't put a plus or minus in between it? It's multiplication. And that's what's different here, right? The shift was always addition or subtraction. When we talk about stretches or the other one, and I'll give that thing a name. I know we have like 1 minute left. It's going to be multiplication. So got to be connected by multiplication. Okay. And this is about as far as I got last time, but I just want to compare one other graph and come up with a name. Okay. Real quick. Let's compare it to like 1/3 x squared. Now, multiplying by 1/3 or dividing by 3 is the same thing. So compare the blue graph to the red one. Did that get stretched? No. What's happening from the blue graph to the red one, maybe you guys can see me still, is just going like this. Right? My arms went down towards the x-axis. What is this motion? Compression. There it is. So it could be, whoa, a stretch or a compression based on the number itself. We'll call it right there. All right. My anticipation is that I will send you something tonight to let you know what tomorrow looks like. Okay. I'll probably send it out by like 9 o'clock at night so you know whether or not you need to jump on by. Okay. Thank you, everybody. I will see you maybe tomorrow, but definitely Tuesday. Tuesday, quiz 0 again. Tomorrow is Thursday or Friday? What's today?
Thursday.
Today's Thursday, so tomorrow? Yeah, perfect. Sounds good. Shoot me a message so I remember. Thanks. Yeah. I think so. I think so. Yeah. Yeah. I'll check to be sure. The 1.1 because you couldn't submit. Yeah, I got that. Thanks, Griff. Bye, Peyton.